Okay, this is video number 3. This was part of the notes. It's the most important handout to have out. What I did was Xerox the 6 problems from the textbook. They're from all different chapters. It does tell you what they are there. I've relabeled them 1 through 6 just to make it a little bit easier. We're not necessarily going to go in order. I'm going to do the easier ones first, which is 1, 3, and 4. Then we're going to do the medium one, number 5, and then the hardest, which are 2 and 6. During a regular classroom period, I put y'all into small groups and let y'all work on these problems, and then we have the students do it at the board, etc. In order for you to get the most out of this, if you're maybe FaceTiming one of your friends in the class as you're watching the videos or whatever, y'all could work on a problem together, see if you can solve it, and then watch it on the video. Even if you're not working with someone, before you actually watch me do the problem, I would absolutely try it yourself. There's sort of 2 parts to these problems. The first part is trying to get the equations that relate to whatever they're talking about in the word problem. Then there's the second part of using algebra to solve the equations. So you could check to see if you had the equations, then pause the video to see if you can do the algebra, or vice versa. So the more you put into how you work with the video, the more you will get out of it. All right, we're going to start with number 1. So again, I think you should read it, see if you can write down the equations, then check the video, then pause it again to see if you can actually solve the equations. All right, Jones, Smith, and Quan are donating money. Jones and Smith gave a total of $325. So we're doing number 1 first. Jones plus Smith gave a total of $325. Smiths and Quans gave a total of Smith and Quan gave a total of $475. And then the first part that I do find students get a little confused on, the Quans gave 3 times as much as the Joneses. So making sure that you have the 3 in the correct spot. A lot of times students put the 3 on the wrong side. As soon as you write the equation, kind of check your work. Let's say the Jones gave $1. Let's say the Joneses gave $1. Then Quan would be 3 times 1, which is 3. Yes, the Quans are giving more than the Joneses. The Quans gave 3 times as much. That all makes sense. I maybe should have said many of you can probably solve number 1 just from critical thinking and playing with the numbers, which is fine. But in Math 207, we want to get up to the algebraic part, actually letting variables represent the values and then practicing how to solve. See, we actually have 3 variables, but we have 3 equations, so it is solvable. One of the videos in the past, systems of equations, we would have x and y variables, and that's why we always needed 2 equations. You need 2 equations to solve for 2 unknowns. You need 3 equations to solve for 3 unknowns. Now, at this point, the algebraic process, there's probably 5 to 10 different ways you can work through and solve what Q, J, and S are. So if you have solved it one way and you have the right answer, you don't necessarily have to solve it the way I'm about to solve it. There's lots of ways. Let's see. Q plus S. I could write that as S equals 475 minus Q. Why do I even want to do that? Well, see, then I can put this into there. So that's going to give me J's and Q's, right? But I also know what Q is in terms of J. So let's write that. So we have J plus 475 minus Q, because that was my S, equals 325. And now you're like, well, I still have a J and a Q, but look at this guy. I can put that in for Q, because it is only in terms of J. Then I'm going to just have J's, one variable, one equation. J plus 475 minus Q. Well, I'm representing Q as 3J equals 325. So J minus 3J minus 2J plus 475 equals 325. I can subtract 475 from both sides. Minus 2J equals minus negative 150. So J equals 75. That's our first one, the Joneses, right? Now you can easily put that right in here to see that Q then must be 225. And then you can, let's see, we have what J and Q are. So you could put the Q in here to solve for S. So S turns out to be 250. So again, lots of ways to solve this as long as you get 75, 225, and 250. I know I have a shadow on my board. I'm very limited where I can set up in my room. All right, so that's number 1. Let's go on to number 3. So if you want to pause, try to do number 3. Few comments on number 3. Let's see, a rectangular room for painting. You notice the room is exactly twice as long as it is wide. Total distance around the room. Please make sure you know that they are talking about perimeter. And I do expect that you know what the perimeter of a rectangle is. Perimeter is 2L plus 2W. Length times width. Length plus width is the perimeter. They tell me that is 87. Okay, so there is one formula, but I have 2 unknowns, so we got to get another formula. I keep losing my problem. Number 3. Exactly twice as long as it is wide. Twice as long as it is wide. Meaning the length is longer than the width. If the length is twice as long, the length is bigger. So yeah, if the width was 1, then the length would be 2. The length is bigger. So that's our second formula. 2 formulas, 2 unknowns. It's solvable. So many different things you can do right now. Actually, I'm going to do it the way that's on my handout, the notes, because I know you printed it. But as I'm doing this problem on the whiteboard, I just realized, actually, there's probably an easier way to do it. But I'm going to keep to my notes. But again, algebra gives you some freedom on the process. So I noticed that I could put this into there. The other way I had noticed was I could have just put an L here, but I'm keeping to my notes right now. So 2W plus 2W equals 87. 4W equals 87. Well, too bad I can't, I got so excited I saw it a different way. Let's erase for a second. 2 times 2W plus 2W equals 87. How about that? I forgot to carry my 2. 4W plus 2W, 6W equals 87. So W is 14.5. If you put 14.5 back into here, 2 times 14.5, you'll get that your length is 29. So I find when students are doing this in the classroom, they forget the perimeter formula, and again, they get a little confused as to where the 2 is going, but those are usually the only issues on number 3. I actually want to make a random comment about real life. It is interesting that they're talking about the perimeter and length times width, all of that, when they're talking about painting. Painting, you paint walls, which is the area of all 4 walls, right? So knowing the perimeter is not useful for painting a room. You would also need to know the height. When would perimeter be useful? If I was needing to buy trim to trim, all around the floorboards, that type of thing. Perimeter, of course it's needed when I'm doing my carpet, but again, carpet is covering the entire floor, which is an area. So it really is more of if I needed to go buy trim. I wish they had written a real life problem. Perimeter does not help you when you need to figure out how much paint you need to paint a room. So just wanted to comment that they could have made this much more real life. Maybe while I'm rambling about real life word problems and ones I've seen in textbooks, a lot of times they'll talk about a backyard. Perimeter for a backyard is useful if you need to know how much fencing you need, but the area of a backyard is useful if you need to know how much grass seed to buy. Those are 2 pretty common problems that you will see in middle school level textbooks. All right, we are going on to number 4. Number 4 is an intersection word problem. Break-even point, I don't think I've used those words yet. This will be the first time. We did talk about finding the intersection when we were talking on that very first day graphically. It all relates. So you're offered 2 different jobs selling whatever, selling cell phones, it could be selling cars, any type of job where you're going to make a commission plus possibly a base salary. One has an annual salary. I just decided to call these different things so I could talk about them at the end. Job A, the first job, you get $24,000. That's your base pay, plus a year-end bonus of 5% of your total sales. I don't know what your total sales are going to be. Let's call that X. So that's the formula for the first one. Base pay plus 5% of my total sales. Make sure you turn the 5% into 0.05. Job B, they're not paying you as much. $10,000 plus a bonus of 12%. So they're giving you a higher bonus, right? So those are my 2 equations. I have 2 unknowns. How much would you have to sell? So they're asking for the sales, right? To earn the same amount. Remember when we were talking graphically on that first day, we talked about the intersection. It would have the same value? That's what we're talking about here. So a lot of times these are called break-even word problems, which at what sales are these two jobs the same, where you're breaking even? It's basically just the intersection. So all you have to do is set these equal to each other. I mean, if you wanted, you could overkill this. I'm not a fan of doing it like this, so let me get my other color pen out. You could call these Y, where Y is your salary, right? Salary equals this, salary equals that. And the question is, what is your sales where the salaries are equal? And that is why we're going to let this equal this, because those are the same variable, Y. So if you haven't solved this, pause the video and solve this. Let's see, I can move the 10,000 that way, so minus 10,000. Now I can subtract the 0.05x. 14,000 equals 0.07x. Now I'm going to divide both sides by 0.07. And I'm going to get 200,000. Wow, I have to sell $200,000 in cell phones in order for these two jobs to be equal. And that's what the question asked. I want to do a follow-up question. I think there is a homework problem in your book that does this also. I want to then say, okay, what if you sell less than 200,000? You now know how much you have to sell to break even. What about if you're like, oh my God, there's no way I can sell 200,000? Which job should you take? Okay, so there's my follow-up question. I'm scared to death. I'm a terrible salesman. There's no way I'm going to sell 200,000. So which job should I take? Make your life easy. I see so many students, they'll say, oh, well, okay, I'll just think of 150,000. Then they have to go put it in there and do all the math on the calculator. Make your life easy. In general, and just in mathematics, we love zeros and ones. They make life easy. What about if I'm the suckiest salesman ever and I'm scared to death and I'm actually going to sell 0? 0 is less than 200,000, right? And if you put 0 in here, these numbers fall completely out. I don't even have to think about them. So yeah, job A is better. If you put 0 in on job A, you're going to be making 24K, and on job B, you're going to be making 10K. So I'm absolutely taking job A. All right, we're going to go on to number 5. This one's a little bit harder to read. Maybe not setting up the formulas, but possibly solving the formulas. So work on number 5 and then come back. You went shopping at 3 stores and spent $167.80 in all. You can call your 3 stores whatever you want, A, B, C, whatever. I like X, Y, and Z. But you can use whatever 3 variables you want. So I know that X plus Y plus Z equals 167.80. Okay, that's one equation. All right, let's do the second sentence. You spent 3 times as much at the first store. So I spent more at the first store as you spent in all at the other two stores. So the other two stores, they want me to add it together. How many times? I spent 3 times as much. So look at this one for a second because it kind of looks a little awkward. This is my first store. I spent 3 times as much. So I spent a whole lot at the first store, right? But here's the tricky part. You got to read carefully that it says you spent 3 times as much at the first store as you spent in all at the other 2 stores, which is the second store and the third store. Okay, so that's here's one formula. Here's another formula. But see how I have 3 unknowns? There's got to be a third formula coming, so I'm going to keep reading. You spent $8.45 more at the second store than you spent at the third store. Okay, second store is Y. I spent $8.45 more at the second store than I did at the third store. So again, just kind of check your work. If I spent $1 at the third store, then yeah, I spent $9.45 at the second store. Yes, I spent more. Okay, I'm good there. Here's my third formula. 3 unknowns, 3 formulas, 3 equations. How much did you spend at each? Okay. Now, again, so many ways to solve this. Please feel free to just work on this for 5 minutes, come back and just check your answer. But if you did not get the right answer, then you can look at one way that I'm going to do it. All right, I see that I could put this in there, right? X equals, all right. And that's just going to give me a bunch of Y's and Z's. Maybe I should mess with that for a second. Let's put that in here. 3y plus z, because that's my x, plus y plus z equals 167.80. Well, we got to work that out. That's 3y plus 3z plus y plus z equals 167.80. Might as well clean that up a little bit. 3y plus y, 4y plus 4z equals 167.80. You know, I'm not going to do it, but at this point you could divide everything by 4 if you wanted to clean it up even more. But we've got this. That's not solvable because there's 2 unknowns, right? But look. So I got y's and z's. But I know that y is in terms of z here. I could stick this in there, and then all I would have is z's. Okay, now make sure you distribute the 4. I can't read my handwriting. Hold on. 8.45 times 4, 33.8. So 4 times this is 33.8. I got to go 4 times z. I have another 4z. So don't get confused. We've got quite a few 4z's here. This one was this one. This was from doing that. Okay. All right, what do I got now? I have 8z plus 33.8 equals 167.8. Subtract 33.8 from both sides. 8z equals 134. Divide both sides by 8. Z equals 16.75. That's what one of them is. So I got my z. And now you can plug him back in to get your y. You just put the 16.75 right back in here. And then you could put both of those in here to then solve for your x. X is 125.85. Okay. So the next one, it's really the language. They used very awkward language. So try to do number 6 and then come back. All right. The fact that they use the words last year and previous year, I swear the first time I read this problem, I think I had to read it about 5 times. And I just couldn't keep up with the words last and previous because in general, they're synonyms to me, but that's not how this problem meant it. Remember, this is not my fault. This is a book's problem. So I ended up, just to try to help my brain, I gave them variables. I called last year B, and then the one before that, last year, the year before last year, I called it A. All right, a store manager notices that sales for last year were 25% over the previous year. Meaning, if you just kind of think about it, they're trying to tell you this company is doing good. It's like 2 years ago they made something, but then last year they made 25% more. So they're growing, they're doing well. 25% over the previous year. That means in addition to. So whatever the previous year was, 25% more than that. 25% over the previous year. So this is really important because you're going to see this come up on a few other videos. This is growth. That, let's just say I made $100. Well, then I made an extra 25 on top of the 100, which would have been a total of $125. Make sure, so this is not that different from my tax on my shopping problems we did the other day. Right? Because tax is adding to it. It is growing your bill when you get up to the register to pay. So this is 1A plus 0.25A equals 1.25A. So again, when you see that decimal, you really need to understand that it's representing 125%, which makes sense because they're growing. The company is doing good. All right. I've missed something in the problem. Let me reread. Oh, and the sales for last year, which is B. Okay, they're about to tell me what B is. The sales for last year were $840,000. Okay, so then they tell you, hey, we know they made $840,000. What did they make the year before that? What they're calling the previous year. So the hardest part of this is just really understanding this part. When I walk around the room, when we do this in the classroom, so many students just have 0.25. Think about it. If you just put 0.25, all you did was add literally a quarter, 25 cents, right? It's 25% of the amount. So I think it's really this term that's the most confusing to students. So now I'm going to divide by 1.25. And I'm going to realize that 2 years ago, what they're calling the previous year, is 672,000. And now it kind of makes sense. Okay, 2 years ago, they made 672,000. A year ago, last year, they made 840,000. Yeah, they're growing. They're getting bigger. This year, I guess they'll do even more or something. So let me repeat something. The most common mistake is to say A plus 0.25. And I was saying that's like you're just adding a quarter, 25 cents. Same thing happens with my tax problems. I don't know if I mentioned the other day. When you're calculating tax, you have to add 5% of the sales. So we were always multiplying that 0.05 times something. You can't just, for the tax problem, say plus 0.05. That means you're just adding a nickel no matter how much you bought, and that's not the way the tax system works. So this one, I think it was just really what got me the first time was the language. All right, now the last one we have is number 2. All right. A town has been using, so this, a lot of growth in here, percentages, we got 3 different years. Town's been using a recycling plan for 3 years. The second year of the plan, then they talk about the first year and the third year. Again, I immediately started getting confused. I didn't want to use 1, 2s, and 3s for first, second, and third. That's going to introduce more numbers and mess up my algebra, right? So I went ahead and called the first year A, the second year B, and the third year C. You could have called it X, Y, and Z. They're just placeholders. Does not matter what variables you use. All right, but this might make it a little bit easier to read through. The second year of the plan saw an increase of 25% over the first year. That is just like the problem we just did. The second year saw an increase of 25% over the first year. So this would have been A plus 0.25A, or if you remember what we just did, you're basically talking about 125%, 1.25A. All right. And let me find the comma there. Okay, the second. And the third year saw an increase of 20% over the second year. Let me put my B there. The third year, see, saw an increase of 20% over the second year. %20 increase over the second year. So what was the second year plus 20% growth? So you could write it like that. But I'm getting way too many variables here, right? Look, you know what B is. You could put that in there if you wanted C in terms of A. (1.2) times 1.25. Gives you 1.5. So this now equals 1.5A. Just in terms of A, because I put that in there. Now, got to be a little more information. The mayor proudly claims during the 3 years we saved $41,250. So all 3 years together is $41,250. So A plus B plus C equals 41250. Okay. Now look, we had B in terms of A. He can go right there. We have C in terms of A. He can go right there. So we've got A plus 1.25A plus 1.5A. So 1 plus 1.25 plus 1.5 is 3.75A equals 41,250. Divide both sides by 3.75. you'll see A is 11,000. And at this point, you can plug that in anywhere. Well, you plug it in here, you'll get C. Plug it in here, you'll get B. B is 13,750. C is 16,500. So this, I did not check, but it probably did some of your homework problems. I'm sure I duplicated some of what I assigned to you and what we did in the classroom. Some of them I may have just saved the harder ones because I knew we would do it in class. But again, all of these are from the textbook. Really good problems. Practice them all yourself. At the very beginning of this video, I assigned homework, and I will see you soon.